Hi, welcome back to the Kinesiology and Personal Training playlist. I'm Kevin Tokoph. Make sure to like the video, subscribe to the channel for future videos and notifications. It's very much appreciated. In this video, we're going to talk about a slightly more accurate way to determine what a target heart rate should be for a given exercise intensity, and then from there we can use that to calculate a range of heart rates for an approximation of the range of intensities by which you do an activity. All right, so basically in the last video, and I recommend you go back and watch the previous one in the playlist, we used a very simple formula to ultimately figure out what the heart rate range should be. And I'm not going to go back and explicitly do this in detail, but just to go back to this real quick, this is what we did. We found the target heart rate range and we looked at the lower limit for the heart rate, which was the maximum heart rate times the lower percentage of the maximum intensity. So this would be, the lower limit would be at 50% of maximum intensity, okay? Over here, this is the upper limit for the heart rate. It's 0.85 or 85% of the maximum heart rate. And whatever this number is, let me get this, whatever this number is right here, that's the lower limit for the heart rate, and this is the upper limit for the heart rate in terms of what it should be between 50 and 85% of maximum intensity. But there's one big flaw with this formula, okay? What if you have two people who have the same estimated maximum heart rate, which we're just going to use this formula, right? Say you have two people that are 30 years old, right? But suppose one of the people is a lot more fit than the other person. So what happens when a person's more fit? Well, if they're more fit, at least cardiorespiratory wise, their resting heart rate actually goes down. So maybe these people have the same approximate maximum heart rate, but if somebody does a lot of endurance training, particularly, running, high reps of weightlifting, low intensity, they're going to have a lower resting heart rate than someone who's sitting on their butt watching TV all day. They'll have a higher resting heart rate. Okay, so this formula that we're going to use right here is actually going to take that into account. Now, notice we're going to use something that we haven't seen before called heart rate reserve. Heart rate reserve is just something that's used in this formula. And all it is you're going to take the maximum heart rate minus the resting heart rate. So the maximum heart rate, again, if we wanted to, we could measure it using like a VO2 max test. Okay, that's one way. Very strenuous. Or we can just use this formula right there. Resting heart rate, obviously you could measure that pretty easily. Have the person sit down for a few minutes, lay down, and after a couple minutes, just take their heart rate. Okay. So very easy, and we can use that to calculate the heart rate reserve, okay, HRR. Okay, when we find HRR, then we can multiply that times the percent of the maximum intensity. Okay, so suppose somebody was exercising at 60% of their maximum intensity. Well, then if they were exercising at 60%, then 0.6 would go in that blank right there for percent intensity. Okay. And then we're going to add on to that the heart rate at rest, or resting heart rate, and that's going to give us a target heart rate at this intensity. So a target heart rate at that percent intensity. Okay, so the best way to do this is to actually look at a problem. Okay, so let's suppose that we have a 30-year-old person, and we've measured their resting heart rate as being 60 beats per minute. Okay. And let's suppose they're going to exercise at 50% of their maximum intensity. Okay, so not very strenuous by any means. So let's first go ahead and calculate their maximum heart rate, because we're going to need that. So the maximum heart rate is going to be 208 minus 7/10 of their age, which in this case is 30 years. Okay, so let me get the calculator out. So 208 minus 0.7 times 30. And again, I'm getting their maximum heart rate to be about 187 beats per minute. Okay? 187 beats per minute. Their resting heart rate, I'm just going to go ahead and write this down, was given to us, or in this case, in real life you would measure that. That's given as 60 beats per minute. Okay? So the first thing I need to do, according to this formula up here, is find the heart rate reserve. So the heart rate reserve is going to be equal to the maximum heart rate, 187 beats per minute, minus the resting heart rate, which is 60 beats per minute. And therefore, the heart rate reserve, let me make sure I get this right, 187 minus 60. Heart rate reserve is going to be 127, also in units of beats per minute. Okay, so there's my heart rate reserve. Now what I can do is plug in this formula right here. So I know that, let me put this, the target heart rate is going to be equal to the heart rate reserve times the percent of the maximum intensity plus the resting heart rate. Okay, so let's plug these in. The heart rate reserve was 127 beats per minute. What percentage of the maximum intensity is this person exercising at? At half of it, 50% or 0.5. And then we're going to add on the resting heart rate, which we said was 60 beats per minute. So 60 beats per minute. And let's figure out the target heart rate for this individual. So it's going to be 127 times 0.5 plus 60. I'm getting 123.5. I'm going to round that ultimately to 124 beats per minute. Okay, so if this person, 30 years old, and again, they are going to be at resting heart rate 60 beats per minute, at 50% intensity, they should be exercising at 124 beats per minute. Okay, now there's another thing I want to show you. Okay, and this is an important point. It's also going to illustrate a physiological effect. Suppose I have another person also 30 years old, and they're going to exercise at 50% of the maximum intensity, but let's suppose they were less cardiovascularly fit, and so their resting heart rate, let's say, is now 75 beats per minute. So I have a second person, we'll call them our client, right? The second client is going to be 50% of maximum intensity also. They're going to be 30 years of age, okay? And then the other thing also is they are going to have a resting heart rate, but this time it's going to be, let's do 75, just to make this really clear, 75 beats per minute, all right? So right now, we already know what the maximum heart rate is because that should be theoretically the same. They're also 30 years old. So let's have the maximum heart rate. Okay, we're going to find the heart rate reserve. That's equal to the maximum heart rate minus the resting heart rate. So the maximum heart rate was what? 187 beats per minute. 187 beats per minute minus the resting heart rate. This time we're going to switch it to 75 beats per minute. Let me go ahead and calculate that. So 187 minus 75. I'm getting that this individual's heart rate reserve is going to be 112 beats per minute. Okay? Notice this person, second person, heart rate reserve 112 beats per minute. This person is 127. One thing the heart rate reserve also shows is cardiovascular fitness in and of itself. Whenever the heart rate reserve is higher, meaning there's a larger distance between the max and the min heart rate, okay, that means that the person's resting heart rate is lower, and usually that means that person is more fit. The person with the smaller heart rate reserve usually is less fit, okay, for people of the same age. You have to compare people of the same age, basically, when you're doing this. Okay, so now we can go ahead and calculate the target heart rate at 50% intensity. Okay, do that in a different color. So the target heart rate, remember that was equal to the heart rate reserve, 112 beats per minute. We're going to use the same intensity just to prove the point, 50%, so 0.5. Then we're going to add on to that the resting heart rate, which in this case is 75 beats per minute. All right, I'm going to go ahead and calculate this. 112 times 0.5 plus 75, okay? And so this person, their target heart rate for the same intensity and the same age is actually going to be 131 beats per minute, okay? So notice something. This person on the top, I'm going to call this the fit person. The fit person is the same age, they're exercising at the same intensity, but their target heart rate is lower than the person who is, I'll call this person sedentary. Perhaps they're more sedentary than the first person. Okay? The person who's sedentary has a higher target heart rate at the same age and same intensity. Okay? Which illustrates, again, the point that when you are not as fit, for a person of the same age, okay, your heart rate at the same intensity will actually be higher. Okay? In other words, if I decrease fitness, okay, I increase my target heart rate at the same intensity. Okay, so hopefully that makes a little bit of sense. And the very last thing I want to do in this video is show you how you would calculate a range of target heart rates using this formula right here. Okay, so let's do that. Let's take, for example, let's take the second client just because it's already written right here. The second client, and let's say I want to exercise between 50%, so 50% to 60% of the intensity. Well, I'm basically going to repeat the same formula. I already have the 50% here, so we need to calculate it for 60%. So the target heart rate at 60% is, I'm going to take the heart rate reserve, that's 112 beats per minute. But instead of multiplying by 50%, I want to use the upper limit here. And I'm going to multiply by 60%, or 0.6. And then again, I'm going to add on the resting heart rate, which is 75 beats per minute. Let me go ahead and calculate this. So 112 times 0.6, and then plus 75. It's 142.2. I'm going to round this to 142 beats per minute. And that's the target heart rate on the upper limit. This is the upper limit. This is the lower limit right there. Okay? So this means that for client 2, the target heart rate for client 2 when they're exercising between, again, 50 to 60% of maximum intensity should be between 131 beats per minute and 142 beats per minute. And that's your answer right there for the target heart rate range, assuming you use this formula right here. And again, this formula is one form, or a more accurate form, of the Karvonen. That's not really legible, but it's Karvonen formula for estimating target heart rate. Okay, this particular formula right here is more accurate than the one I showed you in the previous video. Why? Well, both of them take into account age. Remember in the first video I showed you, the one before this, the first formula took into account the age of the person and not really anything else. This formula takes into account the age, but also, in a way, the cardiorespiratory fitness in terms of the resting heart rate. Okay, so as a result, the second formula here is actually more accurate than the first one. And so basically, if you want to get really accurate data on the person, you'll want to use the second formula, which is this one, this form of the Karvonen formula. And they usually call this Karvonen formula the gold standard for estimating target heart rate. Okay, so hopefully this video gave you a little bit of intuition on how to calculate target heart rate ranges using a similar method to the last one, but again, a more accurate one. Please make sure to like and subscribe. I'm Kevin Tokoph. Thank you so much for watching. Future videos will be up soon. Thank you.